Hello, everyone. Thank you so much for joining the webinar today, Graph Product Selection Roundtable. I just wanted to go over a few housekeeping items before we get started. If you have any questions during the webinar, please feel free to put them in the Q&A chat at the bottom of the screen, and I'll be happy to answer them. We will be recording today's session, so I'll be sending out an email later this week with a copy of the recording. If you have any questions or need any help during the webinar, please feel free to reach out, and I will be happy to assist. With that, we'll go ahead and get started with today's session.
Hello, everyone. I'm Scott Heath. I have with me my counterpart, Brian Hall, and we're excited to chat with you today. A pretty jam-packed session here on basically what we're going to do with graph products, why they're so interesting, why they're so different, and more importantly is how do you actually sort of categorize, score, and get to the meat of this, which is how for your particular solution or use case, what's the right solution. I'll be sort of setting the table. Again, Brian will be sort of taking us through the details on sort of what we're going to do and how we run a scorecard, and then more importantly, what are some of the bigger pictures. And then here in the end, I'll kind of wrap it up for us. So without further ado, we'll go ahead and jump in. For those of you that perhaps didn't or haven't seen Gartner's take on what graph analytics and machine learning and what these are in their world sort of technology trends, this is the way that they're viewing this, is really graph analytics now as this better outcome, more connected data, those kinds of things are all part of what they're seeing out there, which is now moving from sort of level one, which was a SQL or a large data warehouse to connected search, what we're doing in analytics, data fabric, those kinds of things, et cetera, and now moving towards the more explainable AI, but more importantly, this sort of what does connected data do for us? And one of the terms that's been out there for a while is connected data is 10 times more valuable as we start to use it for advanced use cases that we'll see here in a minute. One of the other elements that we do here is, as we step through these, is avoid the blind spots, right? One of the things that Gartner is telling us here is this growth or explosion of growth. What those things are going to do now is really going to allow this integration of machine learning, finding things, learning things, predicting things, to be able to do this deep analytic. And it's no longer just a simple connection of one or two things. You'll hear the term hops today. You'll hear connectedness, those kinds of things. Is really, that's what it's all about, is taking this combination. And that's one of the other things you'll hear today as well, is that graph is actually now an additive capability. It's something that we use in addition to NoSQL. It's something that we use in addition to machine learning, older style investments, those kinds of things. And that's really where we're going. And really what Gartner is doing now is recognizing that this will become a new important ingredient as we start to look at different industries and use cases. What is it really doing, right? So relational databases are great. They do one-to-many resources. They do star schemas and data lakes and those kinds of things. But the problem is that many times it's an unstructured query. I don't know what is connected to other things. And many times relational data, you kind of have to know where you're going when you construct these kinds of queries, and they become brittle over time. The other secondary element here is the performance. If I look at what is a 50 or 80 or a 100 outer table join, it starts to slow down. And if I do something incorrect, then perhaps I can walk an entire table and it degrades my performance. One of the things now is this relationship capability that a graph brings us, is to really save that in memory, do it fast, do it efficiently, because the relationships are what drive this analytic output. Now, we typically can augment these or have what's called a polyglot, which is connecting multiple data sources as predicates. And Brian will talk a little more about sort of how that works. The other kinds of elements here is so many things are happening now. Looking at 2 years, 10 years of historical purchase data in a customer 360, what are the patterns and where these things go and how these are laid out. This is really what we're trying to get at now, is how to take snippets or branches of these. How do I look for patterns sub patterns, larger patterns, historical patterns, how have things changed over time, which is something that we refer to as bitemporal. Those are all things that graph databases do extremely efficiently, and we'll talk more about that today. The next thing that we are often asked about, which is, where am I going with this checklist? And what we've done here is lay out for you a nice, clear and concise, stepwise manner, which is really taking it from the business. I really care about cutting cost and driving revenue. I don't really care about SQL, NoSQL, graph analytics, and all that great stuff. I know I need it somewhere, but why do I need it? But more importantly is, do I need a new graph database? Is it something that I can do today? And this is a nice checklist. It gives you the ability now to walk through this. And the first one on this list is a use case assessment. We'll talk here in a few minutes about what use cases matter. Why does a specific use case drive what you do in a graph? And more importantly, how do you test for the performance, for the cost? What do I need out of my graph database to make sure that it's a good fit? The second element then is in this ROI, which is, just because I'm doing customer 360, what is the return? So what if I get a deeper insight? What if I get a 10% better recommendation? What if I get a 50% better recommendation? What if I am able to make a recommendation never made before, right? It's really aligning that business value. And we can see that in fraud, dependency networks, supply chain, et cetera. And we're going to walk through what those are. Now that I have those two things, now what I want to do is figure out which graph technology is right for me, right? We're going to talk a little bit today about what's called a triple store and what's called a knowledge or a property graph, and which one is right for me, which is the right one to be able to put that together. Then this is not going to be my first and only product in my tech stack. I'm typically going to have 10, maybe 20 or 30 for larger enterprises. And this is just simply, again, one ingredient in making a 3 to 5, maybe a 10-course meal here, is to figure out sort of how it all fits together. The next one of those is then really sort of, what's it going to cost, right? So I've got a lot of cost already. I have staff, I have teams, I have skills. How does the business sort of understand what they're paying for, what they're getting for it, which is why we started with that business use case at the top. And then we get our project started, and now we have to go off and go do that. So this is where we're going to go today. And now let's talk a little bit about those use cases, right? So the way we do this over here on the left, so this idea today of customer prospect 360, fraud, deep link analytics, entity relationship, things that have been done in the past that can be better and stronger now. Things like transportation or logistics, better routing, smarter logistics to get us there, supply chain, energy, et cetera. But this is now a very interesting sort of bringing together of what these are, and what it shows us now is this business value. This shows now how each of these use cases potentially can interwork together, how these planners, customer reps, and whether it's fraud as well, right? They all sort of have this interrelationship with each other. And the most important thing then is, just because you may start with a simple use case, which may be recommendations or something like that, those recommendations may also be linked to fraud, right? So just because, you know, I have one use case here, I may even look at governance at the bottom, or compliance or regulatory. And the point here now is that all of these can work together, and a graph database can support all of these. And you may start with one of these, but in the end, you need to take these into account, if you will, as you start to look at the performance and sizing that Brian's going to talk to us about today. Now, what does this mean, a customer 360? Well, a customer 360 is typically everything that you and I have ever done. Well, in the case of a graph, each of these hops, or these links, if you will, which each time I bought a product, did I recommend the product to someone, and then they bought a product, and so on and so forth. These are all very specific links. And when we refer to a term that we'll use today is something called a deep link. You may have different nodes and vertices, as what we'll learn here in a minute. But some of these may be 9, some of these may be 100 levels deep, depending on your use case. In a fraud use case, we may be looking at 40 hops, which is now potentially 100 table outer join to look at the very end of that link, where was the fraudulent transaction? Or in customer 360, we may see something here that's wide. So I may have bought millions of products over time. I may have millions of shallow connections as I recommend those parts and pieces, and I may look at supply chain and other kinds of use cases here, where I have millions of wide parts of things that are in an SKU or BOM. And part of this now, as we start to think about this in our testing and what we need, this is why your use case matters so incredibly, is because this is the kind of query pattern that we need to go test against which of the vendors, which of the products that are out there, to figure out which one performs the best, which one can give you the best outcome. Now, Brian's going to walk us through a different category. Today, we're going to focus our quality time today on property graphs. There is another set of products, if you will, called triple stores. And you can see here, these are kind of the usual suspects, as we like to call them. Triple stores are typically ontologies, other kinds of unstructured data, things that show hierarchies, those kinds of things. And the way it stores the data is a little different. And again, Brian's going to talk about that. We're going to talk more about the property graphs, which are more called knowledge graphs, which combine the sort of hierarchy capability in addition to deeper use case, as well as wide kinds of things like that. And so what we're going to do is spend our quality time today on that. And you'll notice our friend down there, Amazon Neptune. Well, they were actually part of a triple store, and they actually do a little bit of a property graph. And so they're one of the few that kind of crosses or straddles the fence between those. And again, Brian's going to walk us through what those look like. So that's a good table setting there. Now, what we started this off with on my side was, why not use them both? And that's really what we see at Expero here, is that traditional SQL databases, NoSQL time series databases, search and those kinds of things, Brian will touch on that. But ultimately, what we're suggesting here is that a property graph can be hugely valuable. There are certain connectivities, certain relationships that really can make it fast, real-time analytics, as well as augment what we're doing in machine learning that's very different from these other kinds of tools. And so what we're going to go on today is this concept of using or adding a property graph, and why it can be so revolutionary for your data and your insights. Okay, Scott, property graph is great, but where do we go from here, right? So now that we have all this data, we have the capability of combining these different use cases to go do this. What we'll now do is I'll hand it over to Brian Hall.
Welcome everybody, and I'm excited to be here today. We'll talk a little bit, I'll drill down a little deeper with what Scott set the table with, and talk to you about how you might organize a sort of a rubric to measure your own needs and align them against the available products in the marketplace. So basically, okay, thank you. Scott talked a little bit about the two types of the paradigms of graph. RDF triple stores typically store things in a subject, predicate, object manner. Both of these graphs here on the screen you see are representing the same sort of idea. I know Scott, and I met him on April the 1st. On the left, you see Brian as a person, Scott as a person, and Brian knows Scott. So each of those are stored on the disk in a three element tuple. Typically what we see, these use cases for knowledge bases and corporate data dictionaries and document composition use cases. Whereas the property graph on the right, excuse me, is usually used more for anomaly detection, customer 360, those sorts of things. And while they're similar and they look the same from the outside, oftentimes they're used for vastly different things. Now, before somebody rightly says, "Hey, are you saying you couldn't do a knowledge base, a property graph, or you couldn't do it? You couldn't do fraud detection in a triple store?" Obviously, the answer to that is not yes, but rather these are the trends that we typically see in the marketplace. And when you tend to see trends in the marketplace, we like to call those out. So in broad brush strokes, this is how we see the two sides of the coin shaking out with most of the customers that we see. And next slide. So Scott touched on this at the beginning, but when we engage with customers and we want them to we want to help them pick the right graph database, what we usually insist on is making sure you know not only your first but maybe your subsequent use cases, right? There's no right answer. What's the best graph database absent any sort of specifics, right? So am I looking for fraud? Am I looking for customer 360? Am I looking for a knowledge graph? Am I looking for, I want to find the needle in the haystack or some sort of anomaly or fraud detection, or maybe I'm doing some sort of an optimization problem. So usually what we insist on is to say, okay, you're coming to us for to help you select a product. Why are you even bothering with this? Nobody goes out and looks for a graph database absent a business problem. And you've also probably by this time already decided that my 50-year-old SQL database is lacking in some fashion. So probably you've already got this part figured out. What we would also go back just one, go back, Scott. We would also suggest at the beginning, not only should you have your first couple of use cases figured out, but what we would also ask is that you'd also have data sets and data selected for your very first one. Okay, next slide. So to drill down a little bit on why we press on your data, right? You can, there's no shortage of LMDBC benchmarks, and you can find a litany of comparison studies based on different data sets, but your data matters for your results. We've had instances where we're running benchmarks and all of a sudden we realize that the data is not distributed as evenly as we had thought, right? So when we hooked it up for real, turned out that the most important customers in this Customer 360 application had a very unevenly distributed graph model, right? So our the application could perform well, except for your high net worth individuals, which is obviously not what you want, right? So the distribution of your data matters because it may be different than what you think. Your data might change frequently. We've had instances where reporting scenarios work just fine, but now all of a sudden, if I realize I've got sub-second updates to my database, then my reports may not come back as quickly as I want, or consequently, I don't get the SLAs that I'm expecting. We actually had one instance where we're running a prototype for one customer, and they were missing key components, key data elements with which we could link the data so that their use case could be satisfied. We actually did not have all of the data that we thought we did, right? So once we actually collected it, assimilated it, and loaded it into the graph, we were missing key linkages that unlocked the value for the use case. And then your data, like when you end up running this prototype or whatever sort of bake-off, what you would want to present back to your customers is their data, right? Nobody wants to see some generic paper lining up two different data sets that have no meaning for your customers. So I cannot stress enough how much having your data run through this exercise is important. Next slide. Aligned with making sure you've got your data, invest time with your customers to figure out what is important to them, right? Is it uptime, right? Do I need it? Can it never go down, right? Do I need 5 nines or 8 nines, or is 3 nines enough, right? That sort of thing matters. If I'm running simple reports or I'm doing batch OLAP jobs and I do them daily, then I don't really need uptime. Maybe what I need on the right side here is algorithmic efficiency, right? If I can run my algorithms in a shorter amount of time, I don't need it to be up all of the time. Do I need it at scale, right? Maybe my departmental answer is just fine, or maybe it's not. I need the power of the scale, right? Maybe I've got fraud going across business units, and each business unit has a completely functional departmental anomaly detection solution, but I'm missing all kinds of opportunities as they span across business units, right? So maybe what you're really looking for here is scale. Or last but not least, developer or organizational productivity, right? Suppose I've got an entire group of people that are .NET developers, or I've got a whole bunch of people that are Java or Go programmers or JavaScript or what have you. Maybe what I really need to do is know that the most important idea here is something that is good enough, my solution is good enough and easy for me to fold into my bigger ecosystem. So spending a little bit of time outside of your business problem to know what is important in your situation and get concrete with your customers. Next slide. Don't reinvent the wheel. Many of these graph vendors, they offer a lot of the very sophisticated algorithmic solutions out of the box. Lots of graph algorithms have been around for millennia, and many of the graph vendors actually provide clustering, PageRank, similarity, centrality, these things out of the box. You don't have to write these things anymore. Same goes for a lot of the machine learning best practices. Louvain, GCNs are the most notable. Next slide. So each of these property graphs is different and usually can be optimized for your particular need. We've done work with several of these with a litany of referenceable customers. So lining up your particular needs against what each of these vendors has to offer is really a matching situation. Next slide. So let's talk a little bit about each of these detailed features that may be important in your case, right? So multi-tenant solutions are important if I've got I've got multiple teams that need to be looking at the same instance at the same time. We talked a little bit about cross-departmental situations, but maybe I've got some sophisticated security system where I need to have some teams that span business units and some teams that do not. Scott already talked about the wide and deep queries. Imagine trying to do 20 hop queries with outer joins that each of which may or may not be there, or wide variability depth first traversals. So different vendors work different, perform better on each of these. Bitemporal and time series. These are not necessarily unique to graph solutions, but for many of the use cases, when things happened and the sequence of events is often a key piece to the use case, and knowing how to store and retrieve and scroll through time and a sequence of events is a key important detail. Subgraphing is an important feature for some cases where maybe I want to carve out a subset of my entire graph and do subsequent processing on my own solution, right? So perhaps I'm doing some computation on April transactions and Scott is doing things on May transactions, and we don't really want to be affecting each other, and the ability to subgraph to carve that out and pull it back might be worthwhile for us to process parallel. Leaning into parallel processing and multi-threading, oftentimes you've got a big data set. Most graph use cases are whole graph analytics. Opposite to what most SQL and data warehouse projects require. What you see here is oftentimes the use cases require you to cover the entire database, right? When was the last time you wrote one query or one job that actually ran across all the rows in every single table of your entire SQL database? That use case almost never exists. Consequently, what you see here is the parallel processing and multi-threading, where maybe I can take a 1 terabyte database and shard it across 10 different servers. What that allows me to do is both keep hardware costs down and then also have computational performance where I can do 1/10 of the job across each of the 10 nodes and then compose the answer once they're all done, right? So parallel processing and multi-threading is something you see frequently. acid compliance and eventual consistency. What if I've got a point of sale situation where each and every transaction coming in may affect my whole graph analytic job, right? So how do I handle writes? Am I actually writing once and then having to copy it over to the other nodes? Or do I have a sharded system where I can keep track of these in an ACID compliant way versus relying on eventual consistency? And then machine learning and notebook integrations. What we find oftentimes is the graph database is not the end all and be all for all of your analytic needs. And oftentimes what you find is that maybe my graph database requires some pre-processed results, and maybe I want to ship that off to a different data science ecosystem, such that it can be analyzed further with other larger data science teams. Next slide. Embedded search. Sometimes I may have different ways that I want to dive into my graph, right? I want to search by a snippet of a word. I can't remember the exact term, but I know the word Scott was in there, right? So I would want to be able to find subgraphs within my graph simply by using some sort of a free text search. Geographic polygons, right? So many of our supply chain or routing use cases require some notion of distance and cost associated with distance, and maybe some geospatial functions allow us to do some more advanced computations such that we can make better predictions on routing and what have you. High availability. Not all graph vendors offer the same sort of clustering across equal nodes. Some of them are in a master-slave fashion where perhaps I have 10 nodes, but I can only write to one of them, and then that one node ends up needing to copy itself back to the other 9 nodes. That may work in high read traffic, but what if my write node goes down right when I'm trying to accept in new transactions, right? So those sorts of nuances within high availability can be important under the right circumstances. This advanced clustering and node clustering abilities, right? Suppose I've got 2 business units, one in Europe and one in North America, and I'd like to reduce the latency, and maybe some workloads I'd like to ship over to Europe because only the people in Europe are needing this. I can actually control the replication and some of the workload to make it either locationally nearby for geographic reasons, or maybe I want to segment it such that my data scientists, every time they launch a big job, I do not go back forward again, Scott, please. Oh, there we go. Such that I don't want my data science jobs to be affecting my point of sale transactions going in. Read-write workload and batch and streaming. We've talked about this a little bit about how different vendors handle writes and replications, but also some load by batch differently than onesie twosie updates, right? So some allow you to shard the loading of the initial graph across n nodes. Some require you to kind of load up one graph by itself and then make copies to the other nodes. And then some, handle up to the minute writes differently. So these are all nuances of the read-write workload. And then last but not least, heterogeneous joins. Scott touched on this before, where maybe I don't have all the data that I need in my graph. I've got a time series database. I've got other reporting databases, and I need some manner with which to logically pair subgraph entries out of my graph and align them up other data stores or other results from OLAP jobs. So sometimes these query patterns can be complex to join, and different vendors handle that differently. Next slide. So once you've kind of got your kind of facets of your evaluation, you want to actually begin to measure, right? So we've got a battery of tests where we can run through that, capture the results, and like I said earlier, with our data distribution, you can find P95 and P99 results where under your workload, you can load it up with 20, 50, 100 concurrent users and ensure that 95% of the time you have response times under 50 milliseconds or whatever your needs are. And then you can kind of see that distribution and feel good that under most real world situations, you're going to be able to meet your SLAs. So that the speeds and feeds are pretty straightforward, but some of the non-functional or the subjective ones are not so much so, right? And this is again is where your mileage may vary. And for instance, what might be more important, computational speed or available talent in the marketplace, right? There's no one right answer for that, and that's where your specifics are important. So without going into it in too much detail, basically what you can do is put together a rubric for scoring. We have a lot of data collected for each one of these, and then we line it up with your needs. Something that may be a real critical need for one customer may not be all that important for somebody else. So that's how we line up our evaluation with whether or not it is important to you. Okay, let's assume that now that I've got my graph selected, now I've got to actually put it to use, right? So I've picked my graph technology, and now I've got to figure out how does this thing fit inside of the rest of my ecosystem. And it's complex. Look, we get it. Nobody picks a graph database as the first compute infrastructure inside of their ecosystem, right? Nobody walks in with a blank whiteboard and says, first thing I'm going to do is I'm going to put a graph database right in the middle, right? We've got to play nice in the sandbox with a litany of other items, right? I've got cloud platform selections, I've got analytics and search, I've got a big batch Hadoop jobs, I've got all sorts of things that I've got to interoperate with. I've got messaging and streaming data that I've got to ingest, and I've got front end access patterns that I need to be mindful of. So next slide, Scott. So when we start thinking about all of the disparate technologies that we've got to work within, we like to look at it in this sort of a layer cake where on the far left side you see data coming in from somewhere. It could be source data coming in from other databases. This could just as easily be a sequence of sensors coming in from some IoT solution. But in some sense, I've got source data coming from somewhere, and then I've got to somehow map it, get it in. There may be some advanced machine learning or entity resolution. I may do some sort of pre-processing as it comes in. Then I get it into my graph layer. At the same time, from the right side, I've got some user interface. I'm consuming the data somehow. That oftentimes it's a web page or some visualization. It doesn't have to be, but some user is going to be consuming this data in some way, and I've got to be mindful of the APIs with which I'm going to provide access to my graph. So next slide. So one thing that we focus on early on is aligning with your existing investments, right? Probably everybody on this call has some of the logos that you saw on the previous screen. So what we end up doing is trying to itemize what you already have in place and try to leverage that, right? If you've got many years and big investments already invested in certain of these technologies, certainly you don't want to bring in something that's going to cause you to have to rewrite something or rebuild it, or repaving the cow path, as you will, as it's said. And those also imply not just the technology investments and the checks you've written for these other vendors, but the skill sets that you have accrued over time, right? If you've got an entire group of Java programmers, you don't want to be bringing in something that's only C++ or Go, right? So we want to be mindful of not only the existing technologies, but the skill sets of the people that you already have to bring to bear to this project. Next slide. So let's look a little bit about, we've picked the graph database. How do we end up going about getting some of this data into the graph coming from wherever it's coming from? Usually what we end up doing is some messaging mechanism, right? So Kafka and Confluent is one of the most predominant ones that we see out in the marketplace, but it does not have to be Kafka, right? There are many messaging options, and many of the graph vendors provide out of the box connectors. So if you've got Kafka, for instance, many of the graph vendors, they provide out of the box connectors so that getting message-based data into your graph database is as simple as using one of the connectors already created for you. Conversely, a lot of the initial batch loading paradigms are a bit different, right? So you've got a big batch or file-based data load paradigms. Some of the vendors allow you to take a certain data set and load it across all of the nodes in your cluster. Some require you to load the first graph and then copy it over. So this is another thing to be mindful of, in the sense of, am I loading my graph frequently? Am I blowing it away and loading it fresh every night, or am I loading it once and then just making updates day to day as they come in? So these are all things to be mindful of, and as well as the ACID transactions and eventual consistency that we talked about a little bit ago. Next. And then what sort of notebook integrations do you support, right? So what we end up doing is not only looking at how to get the data in, but are there mechanisms with which we can ship the graph query results or pre-processed graph queries and OLAP results back to other notebook and data science environments, right? So it could be some sort of a notebook environment. It could be other OLAP processing engines like Hadoop or Spark. But in any event, how do you get this sort of data out to, where else do you need it to go inside of your ecosystem? Next slide. All right, so now we've talked about the graph and how do we get data into it and where it ought to go. How do we end up consuming it, right? So I've got this user interface that needs to consume all of the great data that we've prepped and loaded into our graph. So what we end up seeing oftentimes is the custom programming, API access. Usually in one of these programming languages that you see here, Java, Python, JavaScript, some of the C variants, and Go are the things that we see most often. We should make sure that whatever graph vendor you select aligns with your API programming language of choice. And many of them provide out of the box visualizations, right? So I would love it if my business users could create their own dashboards. I don't have to create a web app and give it to Bob over in finance, because Bob knows how to hook his Tableau dashboard up to get the data that he already needs, right? Moreover, some toolkits are out there. There are many open source options, but there's some toolkits out there. Those of you who follow the graph industry, you recognize many of these names, and they allow you to hook up to many of the graph vendors and kind of see node charts walking through your graph database. And then not to be forgotten is admin tooling, right? So many of the graph databases you see do not have the analogous, you have some sort of a SQL window or Erwin or a BI powered tool, some sort of admin tooling so that I can model my database and see what's in there and kind of inspect my schema, those sorts of things. That can be an important efficiency gain for larger customers. So let's talk real quickly about what we end up building oftentimes in our graph projects. If you look here on the left-hand side, you've got a typical cube that you might see in a normal BI or data warehousing project or a SQL database, but we're not always showing tables and cubes, right? So given this, if my data might be stored in this way, I can still imagine that I might need bar charts or scatter charts or pie charts, or there's nothing inherently tied to the way the data is stored, on the disk that dictates why I need, one sort of visualization versus another. However, that seems to be not so true with graph. What you see is almost every graph vendor and almost every graph solution, they show you connected data and you're clicking and walking around through the data. So we ask, why is that? Why do I not need pie charts in graph databases? So we always ask, what is it that you are trying to convey? Because some of these visualizations actually help you get better and more informative applications out to your customer. And then when you end up needing to use a node chart, right, what are you trying to infer from this, right? So not all node charts are the same, right? I might be trying to imply some dependency, and A implies B implies C. I might be trying to categorize or match things. I might try to be clustering things and saying this stuff on the left is different than that stuff on the right. Same with similarity. And so anyway, the point of this slide is really to say not all node charts are the same, and be mindful of what you are trying to convey with your node chart. Scott?
All right. Well, Brian, that was awesome. I think what everybody hopefully has taken away from that is that, look, there's a lot to this in this ecosystem and how graph fits in. And what I'm going to do now is sort of finish the final pieces here. So now that we've talked about sort of what these other elements are, we've identified sort of the solution, the assignment, we picked our graph, data structure, et cetera. What we're now starting to look at is this ability to basically start and figure out the total cost for what that starts to look like. And then finally, let's get started. So there are some hidden costs that are part of this. So as we start to look at the different vendors, if you're looking at on-premise, you're looking at cloud or what those are, there are some gotchas out there, right? So in some of the cases in the clouds, you need to be careful of what are called IO costs. So just because you've purchased what those are, we need to sort of figure out what those are. Make sure that you kind of know what those different elements are. The other thing then is machine learning. A lot of times the tools that are out there, there's some more sophisticated versions, and they can be expensive, especially as they overlap and how they sort of figure out what those are. Make sure that you understand clearly what those connections are, because your cost can drive up quickly. The other thing then is on premise, right? So do you already have an ETL? Do you need to purchase, move from an open source into a paid for version? Sometimes you do, and you may need to pay up on those, but you need to factor those into what some of the costs may be. The other thing then is power, space, backup, offsite, hot and storage, right? OpEx and CapEx kinds of things. Is, do you need all of this data in hot graph data storage? Sometimes you do. Sometimes you're looking at a full 10-year, as Brian mentioned, looking across the entire graph, and you're spanning the entire organization. In some cases, fraud, that's what we have to do. So you are going to need all of that. Some cases, I'm only looking at certain subgraphs. So I may be looking at rolling windows. I may be looking at regions, those kinds of things. All of those will certainly factor into your total cost on what we start to see there. The other thing then is, when Brian mentioned how to run those space algorithms, how to run that capability for wide, deep, complex queries and those kinds of things, being able to shard or not shard, having an individual box versus spreading it out over many less expensive boxes, right? All of those kinds of things here vastly will in fact impact your hardware, your cloud storage, all those kinds of good things, and whether it's high availability or not. That's why a lot of times the importance of taking a quick look, doing a proper sizing, not just the back of the napkin, can be highly, highly valuable, because in 6 months or a year, you don't want to be standing in front of some technology committee saying, my gosh, we've changed dramatically. Some of the graph vendors actually shrink the footprint of the data, the way they store it in a graph versus the way SQL does. So these sort of subtleties are certainly things that are very important. The other thing that Brian mentioned was this intangible kinds of things. Not just the simple studio or tool that you use to go in and set up the schema or your instance or your data model, right? It's how easy is the tool to set up on a server? How easy is it to maintain over time? Does it really allow you to go from one server to multiple servers? That flexibility, if you will, the brain damage that it takes to sort of manage and monitor. And more importantly, how many human beings does it take, right? Are the skills of these people, are these standard skills that you can get? Can you create a center of excellence internally that you can continually train and grow your SQL resources? Many of the products, it's a very, very straightforward leap from using SQL or some of the traditional style data structures into a graph. It's just different, right? You need to learn it. You got to do it wrong once to figure it out how to do it right going forward. Then you talk about the people. Is it exciting that people really want to be a part of this new technology? Most of what we find is that is absolutely the case. People are excited to learn this new technique, use a new model, knowing that the people who support the current ones are as valuable, if not more valuable now, as we saw that sort of connected picture that Brian showed us here, which is how do I can just continue to do this, right? Can I go find these skills in the open market, right? Bringing these people in to be able to enhance your current team, get them up to speed to become experts as well. Okay, now we have this sort of combined scorecard. Now what we've done is we've taken the scores that Brian talked about, this idea of a technical total cost of ownership, all these other third-party communities, you know, what these are, these intangibles, how easy is it to do business with this graph vendor? This now gives you the best informed choice. And this is something that we highly, highly recommend, which is an informed buyer typically does better, really maximizes the value out of what they're doing as opposed to maybe using it and getting frustrated and sort of throwing it away. And people saying, grr, it's the graph. A lot of these things are the same, as I like to say, the same rules of gravity still apply. You still need to use good hygiene. You need to check in. You need to check out. Do these products do that? And with this scorecard now, you have a fair and balanced sort of approach on what you're doing. And when you talk to executives and other folks, you can say that, look, we've tested this and our data drives to a certain conclusion. Okay, so now that we have that in hand, what is it that we may want to go build? These are examples, and if you're familiar with Expero, you've probably seen these before. Certainly come to our website. But this is now the way that we see things like at the bottom down here, time series. We see the ability to do that by temporal or standard temporal. We see the idea of journey matching, the idea of scorecarding things, looking for similarity, and then sort of that node chart that's there. But now what you start to see is this sort of combination of different elements, right? Which is this ability to sort of show humans basically to say, how do I interact with this? Well, in these cases, nobody's coding, right? The ability here now is to allow normal sort of people in the world that don't know much about graph. The next thing is this is now in healthcare. Now I can see sort of this combination of what we call a Sankey chart down below, which shows a customer journey. Then I can interact now with a graph and I can see temporal and I can see sort of standard kinds of things here. This allows us now to use that predicate of perhaps a time series, combining that with a graph query to see a node. And then we may even look at SQL data to look at Fring and Farmington in this case. But again, the goal of this now is to see things like pathways and journeys to go do that. Energy, right? Nothing bigger than a deep 100 or 500 node interconnection in a circuit or some sort of electrical grid or a gas pipeline. The other component here is sort of connecting that to a machine learning to do forecasting, to be able to do unsupervised learning and timeshare to be able to do that. This ability now to combine both KPIs that look simple and easy, things like geo charts, and then finally this deep or network investigation is sort of really what graph can do at a very different scale than others. Now we can see things like fraud, right? We can see standard, like Brian mentioned, sort of standard heat maps. Those are still queried out of a graph database, but now I can sort of give information or highlight as I drill into those node charts. I can do weighting and scoring at a much faster level and a much deeper level that I can sort of show these as what look like normal sort of standard dashboards. Now, again, I can also create these as consumable data inside of Tableaus and other kinds of dashboards to go do that. Okay. This is another fraud investigation. This shows now sort of a full linear scale. As Brian mentioned, groups of collaborating investigators. You may have 100 groups of 3 to 5 people. One may be looking at cyber, one may be looking at actual transaction fraud, so on and so forth. And they're interacting with machine learning and then seeing what the visualizations are. At some level, they're combining machine learning and graph algorithms to come up with the best recipe or best scenario for how you find things. And as we know, fraudsters change on a daily basis. And so this is something that's constantly going on. But now you start to get a feel for what these screens look like in context of other data and other data sources in sort of one logical flow. Supply chain and transportation, we mentioned logistics and routing. What are the fastest path? What's the less risky path? Show me where people go or have gone before. I see things like supply chain for troubleshooting, root cause analysis, capacity planning, dependencies on parts and pieces across the globe these days, and then being able to show simplistic dashboards to executives. Again, this is the way Graph sort of makes these things better and stronger in sort of the outcomes, increases accuracy, et cetera. Again, another example here, which is a what if, right? So the ability to what if on thousands of nodes could be a 100 table outer join, and then to be able to run what are all of the potential outcomes. That's something that's crushing in most SQL kinds of environments. And again, this is something that we can do with ease and at speed with a graph database. We can start to see where these cause and effects are, and then in combination with a visualization here, a human or a layperson can sort of see what that is. They may know that graph technology is behind the scenes, but again, they get their job done faster and drive towards an outcome or an ROI. Okay, so now that we've done all that, you as a team are now ready to go forth, start to be knowledgeable in how you approach looking at kind of what kind of graph technology you need, looking at your use case, trying to identify from a business perspective, what is it the business really needs? How do they need it? And more importantly, how does that solution fit with what you already have? And then finally, this sort of cost or total alignment around making sure that it fits within your budget and within sort of your guidelines. The last final parting thought: don't let anybody tell you that graph is the silver bullet. You just pull it all out and throw it in a graph and magic will happen. You will be sorely disappointed. However, if you do accept the fact that graph is an important new ingredient, using my cooking analogy here, then you will indeed become the 3-star Michelin chef, and that your outcomes and what you're going to do for your business will be very, very exciting. So with that, questions?
Thank you, Scott and Brian. We did have one that came through. Do you have a rubric already prepared to evaluate?
Yes, we have several. And as we mentioned today, there are many different types of those for industry and use case. And please reach out to us. We have many different ones that we can share, and absolutely. And then Brian also mentioned we have testing harnesses for different kinds of specific SLAs and performance statistics.
Okay, thank you. Just as a quick reminder, if you have any questions, feel free to drop them in the Q&A box or in the chat. The presentation will be shared. I will be sending out the link to the webinar recording tomorrow. I think that just came through. And there was another one. How long does this take?
You know, Brian, usually, you know, we can do a rapid sort of proof of technology in a short period of time. What do you see normally for a proof of technology?
It's usually gated by the number of vendors you want to evaluate and the availability of the data, right? So it can be done in as little as a week, sometimes takes on the order of a few weeks. That usually, you know, if I didn't say it enough times earlier, having the data and the use cases thought through ahead of time can shorten that. but it's not a month's sort of a thing. It's not a month sort of a thing, and it's not hours. It's on the order of probably 1 to a few weeks.
All right, thank you so much. Do I need training before I begin picking a selection?
I think there's two parts to that. On the business side, no, it's really more of a sort of a workshop, maybe a 1 or 2 hour sort of understanding about why a graph is different. And then Brian, what would you suggest on the technology side?
With respect, you don't want to get trained. You don't want to get trained on on the second place graph vendor, right? So you want to make sure you know what you're going to do before you invest the time getting prepared. One aspect is actually the simplicity of the query languages. So, one of the other things we talked about was making sure that this selection aligns with your existing skill set in-house, right? So some of the query languages are more straightforward than others, and that so kind of just simple query. If you learn SQL, most everybody already knows SQL, so some of them are much closer aligned to SQL than others. So that would be one part of it, and then to the extent that you have some sort of a cloud provided or on-prem installation, you might need some admin training depending on the details there. Did that answer the question?
Yeah, I think so.
Sorry, go ahead.
I just got one here. It seems like there's a lot of small graph vendors comments on AWS Neptune. Will they wipe out other vendors? Well, if experience has taught me this, is that no vendor ever wins by saying that they're going to wipe anybody out. But I can say that because of what Brian pointed out, each of the vendors is so completely different. I think they'll all be around for a while. Now, market pressure and pricing and adoption are always part of that. Today, it's been really interesting. We see a very large spread in all of the different property graph vendors, in addition to some of the even smaller triple store vendors. There seems to be a home and a heart for each of the vendors out there, and sort of adamant user groups that love each of the vendors. Now, depending on your use case, a lot of times these performance specifications sort of bear their own fruit. So for us to take a side, that's not really a thing. I think, Microsoft and Google in the cloud, those kinds of things, those guys are going to be at war forever. And there'll be new ones that'll probably pop up in there somewhere. So I think it's a very analogous kind of situation. Brian, your thought on that?
Yeah, I would say that consolidation has begun. Wiping out is different than getting acquired. So some of that has already begun. Neptune was the byproduct of an acquisition. As OrientDB, through a series of acquisitions, is now underneath the SAP umbrella. So it's not unreasonable to believe that more of that will continue to consolidate. But in terms of one wiping out many of the others, I think they're too different for one paradigm to win out in every case.
That's right. And as we mentioned earlier, Neo4j, TigerGraph, DataStax, even open source Janus Graph, Neptune, Cosmos DB, all of these folks, I wouldn't want to bet against any of them, because who knows, right? Some of them may come out with a killer feature, and then they may start acquiring each other. So I think we all sort of wait and watch as we do this. But again, hopefully what you got out of today was sort of a categorical or statistical way to really sort of find your own selection.
There's one more question that came through, and I think we have time for one more. You hear about native graph underpinnings for graph solutions. Care to comment on what that means?
Yeah, I'll give you the business reason and sort of the business overview, and Brian can give you the technical. Native graph versus sort of a bolt-on. Many times a bolt-on graph was something that was connected to some sort of data source, so like an HBase or a NoSQL style data structure, so that each of them does what they do differently. Native graphs are typically, sort of purpose-built from the ground up for that sort of connective tissue and those things that Brian mentioned, so that me on the business side, what I see is a faster compute time. I perhaps see a quicker or better calculation or scoring for what that is, as opposed to some sort of latency. And then the idea of a subgraph, so I could have 10 business users use sometimes the more of the native graph, because I can span the whole graph as opposed to a bolt-on. And then Brian, on the technical side.
Yeah, I think it's optimizing for two different things, right? So some offerings allow you to swap out the storage layer underneath the covers. That may or may not be value. Again, this is yet another example of why there's no one right answer. Is it attractive to be able to leverage other backing stores that you already have in house, or do you prefer to have it native to the graph instance? That depends. Usually if you don't have a plug and play storage layer, that probably improves performance because you can tie yourself more tightly to one storage layer. But then you don't get some of the benefits of the pluggable storage layer, right? So that's a seesaw on which end you sit on, depends on your needs.
Okay. Well, thank you everyone so much for joining. Again, the recording will be out tomorrow. Feel free to reply to the email with any questions that you may have. We're happy to set up a call if you'd like to discuss your unique use case. Otherwise, thanks again and have a great rest of your day.